Okay, we have here today another interesting integral on the board. We've got 1 over x squared minus 1 squared dx. Okay, at first this looks like a really straightforward integral, and it kind of is, but what I found was there's a lot of places to get in trouble and a lot of places to make mistakes. When I did this one the first time, I actually did it with trig substitution, and it seemed kind of long and messy that way. So what I want to try to do is see if I can manipulate this to start to see if I can get some simplification first. And the main idea I had was I really don't like working with x squared minus 1 squared in the denominator. I would like to get some cancellation. So my thinking was just noticing we have like a 1 here in the numerator. What I wanted to do is I want to have x squared minus 1 over x squared minus 1 squared. This way we'll get cancellation, we just can't change it. So with this manipulation, we still need to make sure we just have 1 in the numerator. So to cancel with this minus 1, if I have a minus out front, now this becomes a 1, we have a minus x squared. Then what I can do is create a second integral, and if I create an x squared, this is going to be a positive x squared, this will cancel with this minus x squared, and we'll have the same denominator. And you can just verify, you distribute the minus in here and add up all these numerators, you just get back 1. But then that's going to allow me to do this cancellation here with one of these, so we just have 1 over x squared minus 1 here. So I think while we have it here, let's just solve this integral separately. And this is actually a really standard integral. We just have dx over x squared minus 1. And I'm just going to use the formula on this. This is going to be the same thing as 1/2 natural log x minus 1 over x plus 1. And we'll have this inside the absolute value. So I'm just going to take this value and we'll plug this back in here and then we'll continue. Okay, next from here, we're just going to focus now on this integral. And I'm going to do one thing to set this up. This x squared in the numerator, I'm just going to rewrite this. I'm going to actually write this just as x times x instead of x squared. And the reason I'm doing that is I'm trying to set up integration by parts. So I'm going to use this using the DI method or tabular integration, and I want to separate off an x. So let's see how this is going to work. I'm going to create 2 columns, one to differentiate and one to integrate. And so I'm going to, for one to differentiate, I'm just going to bring off an x. So then we'll integrate all this other stuff. And the reason I do it this way, this x is going to be easy to differentiate, obviously, but then this integral over here is not bad either. So what I've done is made it easier for myself. So of course, differentiating x, we're going to have 1 here. Integrating this, I'm just going to bring this off to the side just so that we're real clear with what we're doing. So that we're integrating x over x squared minus 1 squared dx. I'm actually going to do this with a u substitution. We'll just call this piece our u. So if I say u is x squared minus 1, then du is going to be just 2x dx. And then if I just create a 2 on this x here, this becomes exactly our du. I don't want to change it, so I'll multiply by 1/2 out front. I think I'll just integrate this over here in this space. So this is going to turn into 1/2 du over u squared, because this is just our u value. But this is going to be the same thing as u to the minus 2 du. So doing this, we're going to have our 1/2. This is going to become u to the minus 1 over minus 1. But let's just take this minus sign and bring it out front here. So this is going to become minus 1 over 2u, bringing the u back into the denominator. But we know our u is this thing, so for this integral, we're going to have minus 1 over 2, and our u value is just x squared minus 1. So now we have part of our solution for this integral here on the diagonal. So let me write this as minus x, because we'll have our x in the numerator, then we're going to have just 2x squared minus 1 here. And then all this stuff here is going to be just another integral. The minus times minus is going to cancel. I'll bring a 1/2 out front, and then we're going to have this integral of dx over x squared minus 1. But the nice thing with that is we already did that integral. That's just this value that we found earlier. This is just a common formula. So we can just plug that in. So let's see what we have. We're going to copy down this minus 1/2 of this natural log expression here. And then for this one, I'm going to have plus 1/2, and this is going to be this thing, so times another 1/2 in our natural log. And then we'll just bring down this piece right here. But now 1/2 times 1/2 here, this is just 1/4. But again, I can just combine this because we've got the same thing here. So we've got 1/4 of these minus 1/2 of these. That's actually just going to give me, if I cancel this one out, this is going to give me here. If we combine these, 1/4 minus 1/2 is going to give me minus 1/4 here. And so for our final solution, we have minus 1/4 natural log x minus 1 over x plus 1 minus 1/2 x over x squared minus 1 plus c, and that's it. And just a couple of quick notes on this. There's actually quite a few different ways to express this answer. You could use log properties to separate out the x minus 1 from the x plus 1. You could bring this into the exponent. You could express this as inverse hyperbolic tangent. There's a lot of different ways. Anyway, thought it was a pretty interesting one. We'll stop it there. Thanks everyone for watching. Have a great day.